In the calculation of the probability of B given A, which is equal to the probability of A intersection B divided by the probability of A, there can be difficulty in the calculation of the probability of A, especially if A can occur in a number of mutually exclusive ways. The following example shows how we can deal with such questions. Kevin has reached the final of a TV game show where he has a chance of winning €100,000. The first thing he has to do is spin a wheel. This will determine which of the three boxes X, Y, or Z he will open. The wheel is arranged so that the probabilities of it choosing boxes X, Y, and Z are respectively 0.2, 0.3, and 0.5. So the probability of choosing box X is 0.2, the probability of choosing box Y is 0.3, and the probability of choosing box Z is 0.5. Kevin then has to choose a card at random from the box determined by the wheel. Each box has a number of winning cards and a number of losing cards. Box X has 1 winning and 3 losing cards. Box Y has 3 winning and 1 losing cards. And box Z has 2 winning and 3 losing cards. Given that Kevin wins the €100,000 prize, what is the probability that he chose box X? So we're going to let A be the event that Kevin wins the €100,000 prize, and B be the event that he chose box X. We need to calculate the probability of B given A, which is the probability of B intersection A divided by the probability of A, as the probability of B intersection A is equal to the probability of A intersection B. They're the same thing. Or in words, we could say the probability of choosing box A given that he wins, which is equal to the probability of box A and wins divided by the probability of wins. So if we were to draw out a circle and split it into 3 sections, we know that the probability of choosing box Z is 0.5, the probability of choosing box X is 0.2, and the probability of choosing box Y is 0.3, so it's easier to see like this. So we know again that this is our formula for conditional probability. So this is where we got this formula from. So calculating the probability of A, which is the probability that he wins, is involved because Kevin could win having chosen box X or box Y or box Z, which are mutually exclusive, which means that they can't happen at the same time. He can't choose both box X and box Y at the same time, and so on, and they add up to 1. That means they are the only options. So 0.5 plus 0.2 plus 0.3 equal 1. There's no other box to choose from, so they are mutually exclusive events and they all add up to 1. So the probability that he wins is going to be the probability of box X and wins plus the probability of box Y and wins plus the probability of box Z and wins. From the given information, we know that the probability of box X is 0.2. So that was given to us in the question. And the probability of win given box X is going to be 1 over 1 plus 3, which is 1 over 4, which is 0.25. So there's 1 winning card over 1 plus 3, 1 winning, 3 losing cards, so 4 cards. As there is 1 winning card out of 4 in box X. We can use the fact that the probability of wins given box X is equal to the probability of box X and wins, which is the intersection, divided by the probability of box X. So we're going to put this over 1 and cross multiply. So we get the probability of wins given box X over 1 is equal to the probability of box X and wins over the probability of box X. So 1 multiplied by the probability of box X and wins is just going to be the probability of box X and wins equal to the probability of wins given box X multiplied by the probability of box X. So equal to the probability of box X multiplied by the probability of wins given box X. We know from the question the probability of box X is 0.2, and we just worked out up here that the probability of wins given box X is 0.25, and multiplying them we get 0.05. So 0.05 is the probability of box X and winning. So likewise, the probability of box Y and winning is going to be the probability of box Y multiplied by the probability of winning given box Y. The probability of box Y, we're told in the question, was 0.3. And the probability of winning given box Y is going to be 0.75, which is 3/4. So we got this from here. So box Y has 3 winning and 1 losing card. So 3 winning, 3 is our numerator, and 4 is our denominator. There's 4 cards altogether. 3 plus 1 is 4. And multiplying these, we get 0.225. And again, likewise, the probability of box Z and winning is the probability of box Z multiplied by the probability of winning given box Z. The probability of box Z was given in the question, 0.5, and the probability of winning given box Z is going to be 0.4. We got this from 2/5 because we're told box Z has 2 winning cards and 3 losing cards. So 2 is our numerator and 5 is our denominator, because 2 plus 3 is 5. Multiplying these, we get 0.2. Thus, the probability of winning is equal to the probability of box X and wins plus the probability of box Y and wins plus the probability of box Z and wins. The probability of box X and wins is 0.05. The probability of box Y and wins is 0.225. And the probability of box Z and wins is 0.2. So adding these together, we get 0.475. And so, the probability of box X given that he wins is the probability of box X and wins divided by the probability that he wins. We got this from our conditional probability formula. So the probability of box X and wins is 0.05. The probability that he wins is 0.475, and this simplifies to 2/19. So, given that Kevin wins €100,000 prize, what is the probability that he chose box X? And that is 2/19. In practice, the calculation of the probability of winning can be laid out in the form of a tree diagram. On such a diagram, the mutually exclusive events are shown as different branches, and as we progress along each branch, we multiply the probabilities. This is shown on the next page, or shown down here, where W stands for winning and N stands for not winning. We don't have to calculate any probabilities we are not interested in. So we're not interested in not winning. So his options were to choose box X, box Y, or box Z. The probabilities were 0.2, 0.3, and 0.5. That was given to us in the question. If he chose box X, he could win or not win. The probability of winning is 0.25. If he chose box Y, he could win or not win. The probability of winning was 0.75. And if he chose box Z, he could win or not win. The probability was 0.4. So again, the 0.25 came from 1 out of 4 cards. So that's a quarter, which is 0.25. The probability of winning with the yellow box was 3 out of 4 cards. So 3/4, 0.75. And the probability of winning with Z box is 2 out of 5 cards. So 2/5 is 0.4. So once we have set out our tree diagram, we just multiply along the branches. So the probability of choosing box X and winning is 0.2 times 0.25, which is 0.05. The probability of choosing box Y and winning is 0.3 multiplied by 0.75, which is 0.225. And the probability of choosing box Z and winning is 0.5 times 0.4, which is 0.2. So it's this or this or this, so we add. So we get 0.475, and this is the probability of winning. Note that the probability 0.25 on the top branch is the probability of winning given that X has already occurred. Thus, the probability of choosing box X, given that you win, or he wins, is the probability of box X and win divided by the probability of winning, which is 0.05 over 0.475, which is 2 over 19 as before. So the 0.05 came from here.